This session, we'll be learning about implementation of process synchronization. Last session, we discussed what is the need of the process synchronization, what is the serial execution, what is the current execution, and what are the problems with the concurrent execution, something like race conditions. What is the problem with the race condition? Inconsistency of the results, which may further leads to deadlock. So to avoid the race condition, there is a mandatory requirement of process synchronization. So process synchronization try to have the control on concurrent execution of the processes. Therefore, it ultimately turn all the process into serial execution concept. So this can be done with the help of critical section. Critical section also called as a critical region or critical segment. So when we talk about the critical section, where it's nothing but a lock, indirectly you can say that it's nothing but a lock. Whenever there are two processes like a process X and process Y, and they're trying to share a common resource, something like salary object, and this is issuing read operation and write operation. And before allowing read and write operation onto salary object, process X has to undergo validation. What is that validation? It's supposed to see that salary object is currently available or not. That means nobody is using it. So according to this case, salary is freely available because I kept idle. Then Rx and Wx is given. So that means the salary is under completely protected. This is under completely protected because it is in a critical section. Now in the meanwhile, as Rx is under processing and Wx is under processing, which are the two requests have come from process X. Process Y is also trying to give a request onto salary in order to access read and write operations. Again, the PY will go for validation. The validation is saying that the salary is idle or not. But right now, salary is busy with the process X. Then immediately our request will be kept under what? Waiting. So here, what exactly happening between PX and PY? So this is what exactly the concept of critical segment. So real-time example you want me to ask, I can give. Like you say, when you go to a mall, there are some trial rooms. Trial rooms are initially vacant, and the trial rooms are completely monitored by a guard. So before a person would like to access the trial room, first of all, it has to see that he has to see that whether the trial room is available freely or not. If it is available freely, as we have taken assumption that it is freely available, then the man can go inside and he will lock the door. That means, first of all, he is testing whether the trial room is freely available or not. If trial room is freely available, he will go inside and keep a what? Lock. When this is locked, and some other person would like to access the same trial room, like a process Y. But again, process Y has to cross verify the trial room is freely available or not. It is not freely available. Even you knock it, it is not possible to enter because it's already inside locked. So therefore, immediately your turn comes into waiting. So how long the process Y would access under how long the process Y will take this salary object unless until the process play unlock. So he will unlock it, the person will come out, then immediately reminder goes to the next person who is under waiting. So he can access. So in the same way, here salary is a shared object. That is an assumption. What is the assumption? Race conditions are only for what? Shared objects only. And I clearly mentioned that let salary is a shared object which can be shared by any number of processes. Therefore, there may be a chance of race condition. So, for example, another example, let us say there is a ticket counter and multiple persons are standing in front of the counter. If multiple hands are put in that particular hole to have a ticket, then the other guy who is servicing you may able to get a confusion to whom to serve the ticket. So that's why the concurrent order will convert it into serial order. Then in that, so one by one person will be accessing the ticket counter. So this is how we will see that the concurrent formation will be converted into serial formation. So the same story here is that so process synchronization can be implemented using a concept of what? Protected block. That protected block is nothing but critical section, where the critical section consists a piece of code which is under shared mode, which may be variable, or which may be objects, or which may be resources, maybe hardware or software, whatever it may be, or it may be memory. All these are, you can call it as a shared mode. So when they are all under shared mode, multiple processes are trying to attack them because they want to get satisfied their own request because an urgent manner. That's why these guys have to check whether the shared resource is currently available or not. Upon availability only, the process can go inside. Otherwise, he has to wait. So how this is possible? How a critical section can be implemented? That means whenever you see that there is a process X and there is a process Y, so there will be mandatory section called a critical section. There will be mandatory section called a critical section. This critical section is an area where the shared resources are under protected format. If a process X would like to access the things which are there, the things which are there in critical section may be resource 1, resource 2, resource 3, resource 4, or 5, 6, 7, 8. First of all, every process has to go for validation. That is what is the meaning of what? Entry section. First, you need to observe that once you enter into the queue, you need to observe that these resources are freely available or not. If these resources are freely available, then after validation, you can access the critical section. Once your task is completed after accessing your shared resource, you need to exit. So another section is called exit section. And this is the first section. Once this is passed, you will be entered into critical section. Once your task is completed, you will be under exit section. And finally, as soon as you exit, then immediately a reminder goes to the next guys who are in the queue. Same story here also will write. The first section, every process has to check entry section. If entry is false, if you are unable to enter, that means your entry condition is false, then you have to wait. Otherwise, you can access critical section if the resource is freely available. After that, you need to go for exit section. Then after that, you can go for what? Reminder section. Therefore, each process has to undergo all these phases or sections in order to access the protected resource. So this is an idea, critical section, critical region, critical segment, where all the shared resources are available in that block. The sections of process, entry section, you need to check the validation. If validation is passed, you will be entering the critical section. Once critical text section, you have to come out from the critical section by saying exit section. Then give a reminder to other process that your task is completed. You have come out from critical section. Before that, there is a non-critical section also there. What a non-critical section? You say that the objects which are not shared all are under non-critical sectional. When you not share any object, then there is no necessity of the race condition and process synchronization. The process synchronization is only for what? When the resources are shared. If there are no resources shared, then there is no requirement of process action, process synchronization, because there is no concept of race condition. Race condition only comes when there are shared resources and there is a fight between multiple processes to access limited resources only. And obviously, in real time, in operating system, you will be given only limited resources. You go to mall, trial rooms are very less. You're trying to book a ticket in IRCTC, trains are very limited and seats are very limited. What not? In real time application, all are limited resources only. There will not be a case of indefinite resources. If indefinite resources are there, there is no requirement of what? All these kind of process management. Now, what entry section? Entry section is you need to cross verify whether the resource is freely available or not. If resource is freely available, then you can access that resource and leaving exit section and goes to reminder section. So you want to access process synchronization carefully. There are three properties we're supposed to satisfy. That is mutual exclusion, progress, bounded waiting. What is a mutual exclusion? No two processes simultaneously can access shared resource. That means there should be a exclusive concept. It is exclusively for you. No two processes can access a shared resource. Only one person can allow critical section one time because the critical section consists protected data, shared resources. So what the mutual exclusion is saying, so more than one process cannot access critical section at the same time. This is the first property we must satisfy to say that we are maintaining or sustaining process synchronization. Second one, progress. What is a progress? Imagine the mall is completely empty, very few customers are there, and nobody is using trial rooms. Only one trial room is available. That trial room is under shared mode. And you observe that person X is going into the trial room. Before he enter into the trial room, he will cross verify whether trial room is freely available or not. Observe that nobody is there inside. Then you can enter, lock it, and complete your task. Come out. So again, the same person would like to access the critical section because this time he wants to check another pair of dress. So again, here he will cross verify whether the particular trial room is freely available or not. If it is freely available, then that person can go infinite number of times to access the shared resource because it's freely available. You can't stop. You can't make any hurdle to the process which it wants to access critical section continuously. If somebody is there and the upcoming process is supposed to be under waiting. If nobody is there, that process can go n number of times. That is progress. Bounded waiting. Assumption there is already process X inside who is accessing shared resources. In the meanwhile, somebody entered, it also wants to access critical section. But we will say that wait, because the previous process is under currently processing, it is accessing critical section. How long the upcoming process has to wait, that should be finite amount. It should not be indefinite amount of time. If a process is taking much time in the critical section, then operating system maybe suspend that particular process. In real time, you talk the same trial room concept. So somebody is already inside and that is monitoring by a security person and other person would like to access that trial room. Then security guard said that please wait, somebody is inside. And he is waiting. How long he will wait? He will say to the watchman or security guard, somebody is taking much time. Then watchman immediately knocks the door and requests the process which is there inside the critical section to come out. So immediately he will come. That's the waiting time of the process is supposed to be bounded, limited. These things you may face in real time like cash counter, billing counters, banks, anywhere. Wherever there is a queue, you will see that all these three are supposed to be satisfied. So what a mutual exclusion is saying? Mutual exclusion is saying There is a critical section. I am protected. There is a critical section which consists of a very important shared object called A. Then this is completely under protected by critical section. There is a process X who would like to access object A. He is checking that right now A is available because validation is success. Then immediately process X is inside the critical section to access A. Once you enter into the critical section, you need to lock it. Otherwise, if it is open freely, then everybody can come inside. The process X is responsible to lock itself. Then it is locked. In the meanwhile, some other process by name PY would like to access critical section. Then immediately OS will say that it is not freely available. Then you're supposed to be under what? Waiting. This is the property of mutual exclusion. Only one process is allowed per instance of time to access critical section. Clear? If somebody say that assumption, the critical section consists right now two process by name Px and Py, then is it following a ME? Is it following a mutual exclusion? No, because critical section should not consist a multiple number of processes inside. Only one guy can able to access. Then what is a progress? Progress, I said that there is a critical section which is completely protecting shared resource. Here, A is a shared resource. Now, there is a one process by name Px is trying to request object A. Immediately we will grant because A is not being utilized by anybody. Then Px is inside. Px completed the task, so he will come out. Px is out. Here Px is in. Here Px is out. Once Px is out, there is no Px inside. Observe. After some time, this is the first iteration. This is the first iteration. After some time, again same process is requesting that I want to go in once again. Yes, you can happily go because the critical section is freely available. No other process is there with you to perform a race. Then Px will be inside. Then after that, after some time, because you're supposed to take critical section only some instance of time, then out. This is what is the concept of progress. As long as critical section is available or shared resource is available, then a process can get a chance to access it. And what is the third property I said? It is a bounded waiting. Bounded waiting. The waiting time of waiting process supposed to be limited. Imagine there is a critical section with object A. It's completely protected. So there is a process X would like to in. Yes, you can in because it is freely available. In the meanwhile, there is a one more process by name PY. He wants to in, but it says that you're supposed to be under what? Waiting. Because already PX is accessing shared resource. How long he will be waiting? This is very important. How long he will be waiting? He will be waiting up to finite amount of time. So the waiting time of PY, waiting time of process PY must be finite. Must be finite. So these are the three important properties you're supposed to satisfy that you're implementing process synchronization well. But it is not compulsion to satisfy all the three. Mutual exclusion is a mandatory. Mutual exclusion is a mandatory to satisfy. Then only we will say that we are implementing process synchronization. This is mandatory. And progress is not that much, and bounded waiting is not that much. So if you satisfy well, if your algorithm satisfy, it sounds good and sounds good, you can carry forward. If algorithm is not satisfying other two properties, it is a mandatory. ME is a mandatory to satisfy. Otherwise, you will face a concept called race conditions. So, what are the solutions to implement process synchronization well? When I say that process synchronization, when I say PS, process synchronization, you see that you are implementing a what? Critical section. This is a very, very important point. You are implementing critical section to avoid from race conditions, to avoid from race conditions. Why the race conditions are coming? Race conditions are coming because of what? Resources are under concurrent execution. Why they are under concurrent execution? Because resources are under shared. Resources are under shared. So that's why you want to implement critical section well. There are some solutions because to implement critical section, you're supposed to follow three important properties: mutual exclusion, progress, and bounded weighting. This is mandatory. All the algorithms may guarantee ME but may not guarantee other two. So what are the algorithms are there? These are the algorithms, very famous algorithms and very famous solutions. Some are software based, some are hardware based. Software based lock variables, strict alteration, also known as a Decker's algorithm. Then very, very important solution, Peterson solution. Then Bakary algorithm. Hardware based interrupts, set and set, test and set lock, exchange and swap instruction. So this is a very, very important Peterson solution. Sometime strict alteration or Decker's algorithm, because Peterson solution is real-time implemented. Peterson solution is real-time implemented. These two are implemented especially in registers. And what are the solutions for process synchronization? And third variety, operating system type, because already we have seen two varieties, software based and hardware based, and operating system type, semaphore, two varieties, counting semaphore and binary semaphore, strong semaphore and weak semaphore. And programming languages type, it is what? Monitor. These are all nothing but what? Flavors of semaphore only. Right now, we are using real-time binary semaphore and counting semaphore. All are real-time applications. Traffic signal management, railways, if you observe, there are only limited tracks to go or to from. See that how the signaling system works well in order to avoid the accidents. When one train is using the track, then other train is supposed to wait a very long wait because the track is under shared resource. That's why the signaling system works well in order to provide proper utilization of those railway tracks. You may take bus routes, traffic management, many are real-time examples. So we will see that how each solution is implemented well. We will start with the lock variables.